In this particular unit, we're going to look at getting energy from electron transfer. But first of all, you should have a firm understanding of what electron transfer means, what that word means. So we're going to spend this lecture looking more closely at the concept of electron transfer, and then we'll build on that throughout this unit, this chapter that you should be reading, chapter 8, and understand some concepts around alternative energy. Okay, so looking back, most of the energy that drives our economies comes from either burning fossil fuels or harvesting the heat energy from nuclear reactions. So in both the case of using the nuclear energy or the fossil fuels as your primary energy source, what we're doing is upon the either chemical change or nuclear change, the heat energy that's liberated is converted to mechanical energy. I think it's important for you all to recognize that anytime there's a change, whether it be a chemical change, a nuclear change, or even just a physical change, energy is involved. Energy is either absorbed by the system undergoing the change or it's given off by the system undergoing the change. And of course, when it's given off, we call that an exothermic change. And that's what we're harvesting, is the heat energy given off when we burn fossil fuels or allow a nuclear change to occur. And sometimes, like in the case of combustion engines, the heat energy from the change is converted just straight into mechanical energy to, to make your car go. Even with nuclear power, sometimes the heat energy is converted just directly to mechanical energy. For example, in the case of a nuclear submarine, some nuclear submarines are just simply powered by the heat energy, heating water to steam, which turns the paddles to make the nuclear submarine go. But in many cases, that heat energy is converted to mechanical energy and then further converted into electrical energy in a power plant. And that can be a conventional power plant, a nuclear power plant, or even on little submarines, sometimes they have power plants and they're converting to electricity as well. So this is what we did last semester. We spent a lot of time looking at the basic science behind how energy is liberated upon these changes. Then we spent another great deal of time looking at all the problems. Now, if we consider that about 90% of our energy needs are satisfied from either fossil fuels or nuclear power, then we recognize also that all of the issues surrounding those two forms of generating energy. Of course, we talked about the fact that we're going to run out of fossil fuels. We managed to pollute the air by the combustion reaction, and we looked at that in great detail. We also looked at the problem with climate change. Even if you can deal with the pollutants, the carbon monoxide, the nitrogen oxides, the sulfur oxides, and whatnot, you still have the big issue of spewing out a lot of carbon dioxide, which is not generally considered a pollutant, although relatively recently the EPA has designated it as a pollutant, so they can start monitoring it and controlling its emissions. But nevertheless, it does cause climate change. And then also, of course, with the nuclear power, although we don't have the air pollution issue or the carbon dioxide issue, we do have the issue with the waste, how to deal with the nuclear waste. So obviously, the way we're doing things is not sustainable. So we're going to spend a little time here understanding, how have scientists and engineers developed newer, cleaner, better ways of harvesting energy. And we're going to focus again, like I said, on this concept of energy transfer this unit. Now, as it turns out, a combustion reaction, is a type of a chemical change in which you burn a fuel and oxygen to give the products carbon dioxide and water. Well, the combustion reaction is also a type of electron transfer, believe it or not. So we need to understand some basic science here so we can understand how we can recognize what is a type of a change in which electron transfer occurs, and then how can we harvest the change in energy from that electron transfer other than just the heat energy, which is something that's very easy to do when you just burn a fossil fuel. So we need to understand some basic science, and then we can see how these applicable technologies have been developed such that the electron transfer can be intercepted and converted directly into electrical energy instead of heat energy. Because as you know, every time you convert from one type of energy to another, some of that energy is lost, or is not lost, but it's transferred into energy that's not useful, just heat, and it's wasted energy every time, so we lose efficiency. So because people have come to understand this concept of electron transfer on a fundamental level, they can bypass the heat part of the energy transfer and go directly from electron transfer, which is considered a chemical energy, to electrical energy.